Hello and welcome to this session of the Advanced Java course. In this session I will show you how you can do proper error handling in your REST controller. I've already opened up my IntelliJ IDEA, and what you see is the little REST demo project that we created over the past few videos, which means we already have an animal controller, which I have opened right here, and we have an animal controller test. Okay. Now what we wanted to create is a new method in the animal controller. We will use a put mapping, so we want to do put requests to insert or create a new animal. In the test, we will start with a test method. I've already prepared that, so I'll just copy and paste it in here. Which means we have a test. We have the update animal by name. We want the put, we need to import that. So we want to perform a put. Animals, the path should be animals and the animal name. We want to do a printout so we can see what actually happened when debugging this test. And in the expectation, we want the status code to be not implemented. That is an HTTP 501. Okay, let's see what happens if we run the test. Our expectation is the test will fail because we have not yet implemented this method. There's no put with the same path in this controller. I've already opened up this page where Gradle prints together all the outputs from our tests, and in the previous run everything was successful. So let's see what happens if you run the test. The test fails, okay, just as expected. Update animal by name failed. Insertion error at line 113. Okay, let's see line 113, exactly what we expected. Okay, let's take a look what actually happened. So what went wrong? I just refresh the page and we see the animal controller test, update animal by name method threw an error. The assertion error was status expected 501. That's what we said. We wanted not implemented, but it was 405. How did that happen? Now, what Spring provides you with is an already pre-registered error handler, which means in this case, for each method that does not have a request mapping, so you call a path, a URI path, and Spring does not find a request mapping annotation or any controller responsible for that path, it will throw an exception. And that's what we see here, the 405. Okay, now that we have a test, we can start changing our code. In the controller, we will write the mapping in a second, but first of all, let's create a new class, which would be the, I don't know, let's call it controller error or controller exception. That's what it actually is. No, I'll do that later. And what we will do is we will use this exception to be thrown in the animal controller. Okay, so what we can do is just extends the runtime exception. Override method, I want a string parameter in the constructor. And now what we can do is we can use an annotation called response status. And what we can say here as parameter for the value of the annotation is we can say response status dot, we wanted it to be not implemented. Okay, so we created our own exception, extends the runtime exception, has a constructor, and it will, what we expect is that Spring will transform it into a HTTP status not implemented. That's what our test expects, status is not implemented. Okay, now that we have this exception, we can use, or we can go into the controller and say, okay, we want a no, not a path mapping, a put mapping. The path shall be same as above, animals, and we have a parameter name. Oh, almost. Here we go. And it should be a public method to return a response entity of animal, because if we create or update an animal, we want to return this entity. Let's call this upsert, because it would insert an animal if it doesn't exist with this name yet, and it would update the resource if it already exists. So let's call it upsert animal. As parameter, we take a path variable, just as in the case above, string name. But now what we do is we simply throw a new controller exception. And we have to give it a name. Or a message, actually. Not yet implemented. Okay, why is IntelliJ? Oh. It does have some problem with this name, but I don't know what it or why it does that. Oh, now I see. I forgot the at in front of the annotation. That's why the builds also failed. Okay, if we run the test now, what does the test do? The test calls the put animals with a string parameter molly, which means this method will be called if I didn't make any typos. This path variable will be mapped to this name. We ignore that. We just throw a new controller exception. The controller exception is a runtime exception, and it has an annotation response status, and it will be translated into a not implemented, which is a 501. As you can see, the test is successful. Okay, just refresh the output from Gradle and update animal by name. Let's rename this so it's also upsert. And we will find it again, but right now it's update and it passed. So one way of handling exceptions or creating exceptions in your controller is creating your own exception. Of course, you would only use this if you have a domain exception. So if something goes wrong in your code and an IO exception is thrown, you might not want to use this method to annotate your own IO exception or wrap your own IO exception into your own exception this way around. You wouldn't want to do that. But you might have a use case where you have an exception and you can throw this exception, which can be annotated with response status. Okay, now Spring offers a second method. Let's say we don't want to throw a controller exception, but I already put it here, not yet implemented. Let's throw a not implemented exception. It's from some internal Java package, but it's just for the showcase. And you could think of an IO exception or anything else. What can we do now? So now we don't need this controller exception anymore, just forget about that. Spring also offers the possibility to write your own exception handler. Okay, so what we'll do is we write a method, public method, and it will return a response entity. And let's say we use a response entity of strings. We don't return an animal, but we return a response status and a string with a message in that. And let's call this method handle exceptions. And as a parameter, it gets a final exception x. Okay, now what do we do with this exception? Well, we simply return a response entity with a status. Oh, it doesn't show up yet. HTTP status. Oh, there it was. Not implemented. No, now we only have a response entity builder. So in the body, let's give it the exceptions localized message, which means from our system we will read the locale and we will read the message of this exception. Okay, let's try this out. The expectation is that it does not work yet because I'm missing an annotation here. Let's start the test and see that it fails again. Now the mapping is there, right? So it's not the same expectation as in the first test. The mapping is there, so this will be called. We will run into this method. It will throw a new a not implemented exception, but this exception is not handled yet, which means this is thrown into the Spring default exception handler, and we'll take a look at what the Spring default exception handler makes of it. First of all, the tests fail. Okay, and here we see that we have a failure in this exception is thrown, failure in line 113, which is simply the MVC perform call. Okay, let's take a look at the result. And we'll see request processing failed, nested exception is some exception. So this exception was not handled by the Spring default exception handler, and it's just rethrown. So that's not what we want. But to the rescue, there is the annotation exception handler. And we have to give it a parameter as a value to the annotation, which is the class of exception that we want to handle. In this case, we are just, for showcasing of course, we are writing a very broad handler, so it handles all exceptions. Okay, let's run the test again. And now the expectation is that this exception is still thrown. It's caught by this method, by this exception handler, and it will return response entity of string saying response status, hey, this is not implemented yet. In the body, we will see the localized message. If we take a look at the test again, we are just checking for the status, so the body is not of any interest right now. The build is successful. If we refresh the output, we will see, okay, upsert enable by name passed. If we take a look at the standard output, let's see if we can find the put. Here's the put. So we can see what happened actually. The resolved exception still known at this point, but returned from this method was a status 501. Oh, the body is empty, so which means this this not yet implemented exception does not have a message. But if you think about any other exception, it might be that it has a localized message. Okay, now that we have an exception handler method inside our controller, we can go one step further and abstract even more. Spring offers aspect-oriented programming. Aspects are a way of implementing cross-cutting concerns. We will talk about those in detail later on in this course, but for now, an aspect is something that comes in from the side and it wraps your code. It takes your code and it takes certain points where it can sort of like a plug in and interject. In this case, we will write an exception handling. We will use this method, and we want it to be applied to all RequestMapping annotated methods. Now, luckily enough, Spring already provides this, which means we can create a new class. Let's call it the controller exception handler. And this exception handler will have exactly one method, which is this one. And just cut it here from the controller and paste it into this new class, into our exception handler. And what we have to do is annotate this with RestControllerAdvice. So an advice is a keyword from the aspect orientation, and this RestControllerAdvice, there's also a controller advice, so we could also remove this. ControllerAdvice is for plain controllers. RestControllerAdvice simply knows that all responses should be written to JSON, for example, so it should not be transformed into a view that you usually use in your Spring MVC. Okay, now the value that we have to pass to this controller annotation, RestControllerAdvice annotation, is the base packages which this advice has to scan. In this case, we'll simply use our package, which is demo. So this controller advice, this RestControllerAdvice, will work for all controllers in this package. So you could also use more packages here, and you could write specific, even more specific handlers for specific exceptions. Here we're doing the most, the most abstract one. But it's of course just a showcase. Just want to show you that you can use ControllerAdvice if you have, for example, a very common error or a common handling of errors of all your controllers. Okay, let's go to the test and see that it runs. Let's hope I didn't make any typos. At least it compiles. Tests run. We expect that the controller, here it is, the controller will throw not implemented exception. It's not caught inside this controller. It will be handled by the advice. So this advice, this aspect, will wrap around all the mapping, the request mapping methods. In this case, also the upset animal, and it should then return a response entity with a status not implemented, even though again we threw not implemented exception from the Spring, from the Sun or Oracle somewhat internal package. Okay, the build was successful. If you take a look, or if you refresh the page, upset animal name passed again, which means this worked. Okay, wrapping it up, you now have I showed you three ways to do exception handling. You can write your own exception and annotate it with a response status. You can write an exception handler method inside your controller, which works just for this controller. And you can use a more broader approach for more controllers using aspects and writing your own RestControllerAdvice, which scans one package, finds all the controllers and wraps all the request mapping methods. Okay, that's all for today. Thank you for watching and hope to see you back soon. Bye bye.